Hey guys, this is Max. I'm teaching you all about DNA replication and all the players involved. Now, as you can see here, we have regular prokaryotic replication fork. Now, replication can start here at the origin of replication. Is going to move towards this replication fork here. There are 3 enzymes involved with making sure that DNA strands separate properly. Now, the first guy here is helicase. He's going to be the one unwinding the DNA and breaking apart these phosphodiester bonds that are connecting nucleotides between the strands. Now, to keep these strands separated, we're going to use what's known as a single-strand binding protein, which is going to do that. It's going to separate. It's going to keep the strands separated from each other, so it doesn't do the good work helicase has done. Now, this guy here is known as gyrase. He's referring to what's known as supercoiling. Now, supercoiling can be either positive or negative, and it means that there's either not enough nucleotides or too many nucleotides per coil. And gyrase can keep that stable, so the correct amount is per coil. Now, the DNA here started. We're going to see here these numbers, 3', 5', is basically the ends of the strands. So, DNA strands go anti-parallel to each other. So the 3' end of one nucleotide connects to the 5' end of another. Now, DNA is going to keep the anti-parallel nature. DNA replicates from the 5' end to the 3' end. So, it's going to want to go towards the replication fork. So, as you can see here, this continuous line is going from the 5' end to the 3' end. So, that's what's known as the leading strand. Now, what replicates that DNA, you might ask, is known as DNA polymerase 3. That is the main DNA replicator for DNA. So, what about this strand, however? This strand is going from the 5' end to the 3' end of the DNA to keep that anti-parallel nature. So, we can't continuously do that as we would with this strand. So, we have to use, this will be termed as the lagging strands. And it is going to create what's known as Okazaki fragments to properly replicate this DNA. Now, it's going to use what's known as RNA primers. Those RNA primers are going to be laid down by primase. And as primase is laying down these RNA primers and continuing to go down the strands, we're going to have what's known as DNA polymerase 1 chewing up those RNA primers to create spaces and allowing DNA polymerase 3 to move in and replicate that DNA. And as we do that, as DNA polymerase finishes up, there's going to be a little bit what's known as a nick left over. And that is going to be fixed by what's known as DNA ligase. They're going to add a couple extra bases or whatever is needed, or a couple of nucleotides, whatever is needed to fill that nick and finish up replication. And now that all that is finished, we would have a fully completed strand of DNA replicated along this strand and along this strand. And that's it. That's DNA replication and all the players involved. Thank you.